Okay, let's dive in. Welcome, everyone, to the Deep Dive. We're back with another deep dive today, and this one comes courtesy of some really interesting source material that one of you sent over. It's a piece from a classic geography text, Certificate Physics and Human Geography, by Go Cheng Liang. And it zooms right in on a very specific, intense climate zone. So our mission, as always, is to really unpack this. We'll comb through the text, pull out the key insights, the surprising bits, the things that define this hot, wet, equatorial climate. We want to figure out where you find it, what makes the weather tick, the kind of incredible plant life it supports, and crucially, what the source tells us about living there, about trying to develop these, challenging, humid, super green parts of the planet. Think of it as your guided tour through equatorial geography, straight from the source.
Absolutely. And digging into foundational geography like this is just so valuable, isn't it? Because a climate zone, it's not just numbers on a chart. It's like the engine driving the whole landscape. It dictates what grows, what lives there, and that, in turn, shapes everything for the people, the history, the challenges, the opportunities. This source gives us a really detailed look at those connections.
Exactly. And straight off the bat, the source highlights something that might seem odd if you're used to seasons changing. It says the most outstanding feature isn't just the heat, but how incredibly uniform the temperature is all year round. We're talking about places where winter, it just doesn't really exist like most of us know it.
That's the key takeaway the source emphasizes right away. So our plan today is to follow the text's logic. We'll start with distribution, where is it? Then we'll dissect the climate itself, the heat, the rain, the patterns. After that, we explore the amazing vegetation, the rainforest. And finally, we'll look squarely at the human side, the challenges and realities of life and development in these areas, sticking strictly to what Go Cheng Liang tells us in these pages.
Fantastic. Sounds like a plan. So let's jump right in and get our bearings. Where on Earth do we actually find this hot, wet, equatorial climate, according to the text?
Okay, so the source is pretty clear on the core location. It describes this climate mainly straddling the equator, roughly in a band from about 5 degrees north latitude down to maybe 10 degrees south latitude. Now, it's not like a perfect line on the map, of course, but that's the main zone.
And it names some huge, really well-known regions within that belt, doesn't it?
Oh, absolutely. It points to the big ones. You've got the massive Amazon basin in South America. That's probably the most famous example. Then across in Africa, there's the Congo basin, equally vast. And heading east, Southeast Asia gets a major mention, specifically Malaysia, and the huge cluster of islands historically called the East Indies. Think Indonesia, large parts of New Guinea, that kind of area. These are the real heartlands described in the text.
All right, so big land masses near the equator. But I was looking at the map, the source references, figure 121, and it seems like this climate type pops up elsewhere too. Maybe smaller areas, like bits of coastal East Africa, or even nudging into the Andes foothills.
Yeah, that's a really important nuance the source covers. The distribution isn't perfectly neat. The text points out that areas slightly outside that main 5 north 10 south belt can still experience this type of climate, or something very close to it. This often happens where local geography plays a role. A key factor it mentions is the influence of onshore trade winds, winds blowing consistently from the sea onto the land. They carry a lot of moisture, so where these moist winds hit coastal areas or get forced up by mountains inland, they can bring enough rain and keep temperatures high enough to fit the equatorial profile, even at slightly higher latitudes. The source suggests these areas might lean a bit more monsoonal, maybe with a slightly more focused wet season due to the winds, but they still share that core hot and wet character.
Ah, okay. So it's not just latitude. It's also about things like prevailing winds hitting the coast or mountains. That makes sense. Adds a bit more complexity. All right, we placed it on the map. Now let's really dig into the climate itself. You said the most outstanding feature, according to the source, is the temperature uniformity. What exactly does that mean?
It really is the most striking thing based on the text. Think about places with distinct seasons. Big swings in temperature between summer and winter. Equatorial regions, not so much. The temperature stays incredibly consistent all year long. The source mentions an average monthly temperature around 80 degrees Fahrenheit. That's about 27 Celsius. But the key isn't just the number. It's how little it changes from month to month. The annual range of temperature, the difference between the average of the hottest month and the coldest month, is tiny. Really small.
So literally no winter, like none at all.
Pretty much. The source is explicit. There's no winter. The high temperature is just constant. Perpetual summer, you could say, temperature-wise.
Okay, that covers the year. But what about within a single day? Does it just stay locked at 80 degrees day and night?
No, that's another fascinating aspect of its consistency. While the annual change is minimal, the diurnal range, the difference between the day's high and the night's low, is also typically quite small, especially the source notes in places near sea level. And it gives some really stark examples to show just how steady the annual temperatures are. Take Singapore, classic equatorial city. Its annual range is just 2.3 degrees Fahrenheit.
Wow.
Jakarta in Indonesia. Even less variation, 1.8 degrees Fahrenheit difference between the warmest and coldest month averages. Even Quito in Ecuador, which is high altitude, its annual range is almost unbelievably tiny, just 0.7 degrees Fahrenheit. Altitude changes the overall temperature, sure, but the variation near the equator stays minimal year-round because the sun's angle is always high.
Less than 1 degree Fahrenheit difference. That's hard to wrap your head around if you live somewhere with proper seasons.
It really is. Colombo in Sri Lanka, another example, 3.2 degrees Fahrenheit range. And then there's this mention of Jahut in the Marshall Islands, out in the Pacific. Records cited there show the daily temperature range can be as little as, well, 0 to 8 degrees Fahrenheit on some days. Especially in those ocean-dominated locations, the stability is just phenomenal.
Incredible consistency.
Yeah.
It paints a picture of environmental stability that's just fundamentally different.
Okay, so that's the hot part, sorted uniformly warm. What about the wet part? Precipitation?
Right, the wetness. The source describes the rainfall as heavy, definitely heavy. Typical annual totals fall somewhere between 60 and 100 inches, which is a lot of rain. But crucially, it's also well distributed throughout the year. The text explicitly says there's no month without rain.
Now, some months might be wetter than others. You might get slightly drier periods, but you don't get a long, distinct dry season like you find in, say, a monsoon climate. Rain is just a constant feature.
And does the source say anything about when the rain is heaviest? You mentioned patterns earlier.
Yes, it links the heaviest rainfall directly to the position of the sun. This is quite unique to the equatorial zone. The text explains that the periods of most intense rainfall often happen shortly after the equinoxes. You know, those 2 times a year around March and September when the sun is directly overhead at the equator. This means maximum solar heating, maximum evaporation, maximum convection, leading to more rain. So in places very close to the equator, you often see 2 distinct rainfall peaks during the year following each equinox. The source calls this a double fall or double maximum pattern. It even shows graphs in Figure 122 for places like Kuala Lumpur and Bogota that clearly illustrate these 2 humps in the rainfall chart.
So not just constant rain, but a rhythm to it, tied to the sun. Fascinating.
Exactly. And the source uses this to contrast with areas maybe a bit further from the equator or more influenced by monsoons. It shows other graphs, Figure 124 for places like Ellerstar in Malaysia and Bombay, Mumbai, now in India. These places are further from the equator and show a very different pattern. A single, much stronger peak rainfall season, usually in their summer months, driven by those monsoon winds. It really highlights how latitude shapes the timing of the rain.
Okay, and what kind of rain is it usually? Is it like a gentle drizzle that goes on for days?
Not typically, no. The source emphasizes convectional rainfall as the dominant type. It works like this. The intense heat causes rapid evaporation from the ground and plants. This warm, moist air rises very quickly. As it goes higher, it cools, the moisture condenses, and you get these huge, towering cumulonimbus clouds. And those clouds unleash heavy, often torrential downpours. The text paints a picture of sunny mornings giving way to these dramatic afternoon thunderstorms, often with thunder and lightning. It's quite a predictable daily pattern in many places.
Violent afternoon storms. Got it. Does the source mention any other types of rain?
It does mention orographic rain or relief rain. This happens in hilly or mountainous areas within the zone. When the moist air moving inland hits higher ground, it's forced to rise. As it rises, it cools, condenses, and drops its moisture as rain on the slopes facing the wind. So topography can definitely add to the rainfall totals, especially on windward slopes.
There's this interesting line in the source. Cloudiness and heavy precipitation help to moderate the daily temperature. That sounds a bit backward. Doesn't the heat cause the rain? How does the rain cool things down?
It's a feedback loop, you see. The source explains it quite well. The intense sun causes evaporation and rising air, leading to clouds and rain, yes. But once those clouds form, especially the thick storm clouds, they act like a giant sunshade. They block a significant amount of direct sunlight from reaching the ground during the hottest part of the day.
Oh, okay. Less direct sun means less heating.
Exactly. And the rain itself has a cooling effect as it falls. Plus, the evaporation of rainwater from the wet ground afterwards also uses up heat energy. So the very things that make it wet, the constant evaporation, cloud cover, and rain, actually prevent the daytime temperatures from getting extremely high, like you might see in a dry desert at the same latitude. This cloudiness is a big reason why the daily temperature range is also relatively small.
So the clouds and rain put a cap on the heat. Makes sense. Though I imagine the combination of constant warmth and all that moisture in the air must feel a certain way.
Oh, definitely. The source doesn't mince words. It describes the climate as feeling monotonous, oppressive, and uncomfortable. It uses the word sticky, which I think most people can relate to when thinking about high heat and high humidity together. This feeling is apparently worse in the interior regions, away from the ocean's influence. The text contrasts this with coastal areas, which often get regular sea breezes that offer some relief from that constant damp heat.
Okay, let's recap the climate then, based on the source.
Yeah.
We've got uniform high temperatures, around 80 Fahrenheit all year, very little change month to month, or even day to night, loads of rain, 60, 100 inches, no real dry season, often peaking after the equinoxes near the equator, mostly comes as heavy afternoon thunderstorms. And the constant cloud and rain actually moderate the extreme heat but make it feel humid, oppressive, sticky.
Right.
With all that heat and water constantly available, what kind of natural world does that create? What about the vegetation?
Well, as you can imagine, those conditions, constant warmth, constant moisture, are pretty much ideal for plant growth. The result, as the source vividly describes it, is incredibly luxurious, dense vegetation. This is the environment that gives rise to the classic tropical rainforest, especially right near the equator. It's described as teeming with life, incredibly green and vigorous.
And the source breaks down the key features of this rainforest into 4 main points. Let's go through them. The first one is about variety and being evergreen.
That's right. First, the sheer variety of plant species is immense. And crucially, unlike forests, where trees lose leaves seasonally, these are evergreen forests. Individual trees might shed leaves here and there, but the forest as a whole stays green year-round. The source lists examples of valuable hardwoods found scattered within these forests, things like mahogany, ebony, greenheart, cabinet woods, dyewood. But it's not just trees. It also mentions lots of other plants, like lianas, those thick woody vines you see climbing up trees, and epiphytes. Epiphytes are plants like orchids and ferns that grow on other trees, just using them for support to get higher up towards the sunlight, not harming the host tree.
So a real jungle of different plants living together, climbing on each other. Okay, what's the second characteristic the source highlights?
The second point is a very distinct vertical structure, a layering within the forest. Figure 123 in the source illustrates this really well. It's not just a solid block of trees. It's structured almost like floors in a building.
Layers. How does that work?
Well, at the very top, you have the emergent layer. These are giant trees, maybe over 150 feet tall, that poke up above everything else, catching the full sunlight. Below them is the main canopy layer, typically between 60 and 150 feet. This is formed by the crowns of slightly smaller trees and their branches spread out and interlock, forming this dense, continuous green roof. This canopy is really thick and blocks most of the sunlight from getting further down.
Right, the ceiling of the forest. So what's underneath that dense canopy?
Below the main canopy, you find the lower tree layer, maybe 30 to 60 feet high. This has smaller trees, younger trees, saplings that are adapted to living in much lower light conditions. And then finally, right down at the bottom, you have the ground layer, below 30 feet or so. Because so little sunlight actually reaches the forest floor through that dense canopy, this layer is often surprisingly sparse. You mostly find ferns, herbs, fungi, things that can survive in deep shade. That classic image of dense, tangled undergrowth everywhere. That's actually more typical of areas where the canopy has been broken, perhaps by a fallen tree. That gap lets sunlight flood in and triggers a burst of low-level growth.
That layer structure really shows the intense competition for sunlight, doesn't it? Everyone trying to get up high. Okay, what's the third characteristic?
The third point is the sheer number of different species all mixed together. This is a huge contrast to temperate forest, where you might find large areas dominated by just one or two types of trees, like an oak forest or a pine forest. Tropical rainforests, according to the source, are defined by incredible biodiversity all jumbled up. It gives a specific figure. In Malaysian rainforests, you can find over 200 different tree species in a single acre. What this means is that trees of any one particular type, say mahogany, are usually scattered far apart, not clustered together in convenient stands.
Over 200 species per acre. That's incredible diversity. And that links to the fourth point the source makes about forest clearing.
Yes, though this refers more to the natural processes within the forest. Large, old trees eventually die or get blown over in storms. When a giant tree falls, it rips open a hole in that dense canopy. Suddenly, sunlight can reach the forest floor in that spot. This triggers rapid growth from seeds lying dormant or existing small plants, creating a temporary patch of thicker ground-level vegetation. It's part of how the forest naturally regenerates and changes over time.
Okay, going back to that point about hundreds of species all mixed together and scattered, that must make things really difficult for logging, right? The source mentions timber extraction.
Absolutely. It's a major challenge highlighted by the source. Because the valuable timber trees, the mahogany, the ebony, are so widely dispersed, commercial logging is tough and expensive. You can't just go in and clear cut a whole area of one type of tree. You have to actively search for individual trees scattered across large areas. Then you have the huge difficulty of actually getting those massive logs out through dense jungle, often without roads, crossing swamps, and difficult terrain. The source points out that these logistical nightmares make commercial exploitation really hard. It even mentions, perhaps surprisingly, that despite having these vast forests, many tropical countries actually end up being net importers of timber, partly because sustainable and economical extraction is so difficult.
So they have the trees, but getting them out profitably and sustainably is the problem. And you mentioned secondary forests earlier. What are those?
Right. The source distinguishes primary rainforest from secondary forest. In Malaysia, it mentions they're called belukar. This is the type of forest that grows back on land that was previously cleared, maybe for farming, and then abandoned. It's different from the original undisturbed forest. Secondary forests tend to have shorter trees overall, the distinct layering might be less obvious, and crucially, they often have much denser, more tangled undergrowth right from the ground up, because more sunlight could reach the ground initially.
Okay, so the primary rainforest is this incredibly rich, layered, ancient ecosystem, but its very diversity and density make large-scale exploitation like logging quite tricky. Let's shift gears now to the people. How have humans traditionally lived in these equatorial regions based on what the source tells us?
Well, the source suggests that historically these regions were generally sparsely populated compared to, say, fertile river valleys or coastal plains elsewhere. The traditional way of life described is one deeply adapted to the forest environment. It talks about relatively small groups, often living as hunters and gatherers, or practicing a specific type of farming, kind of shifting cultivation.
Shifting cultivation, that term keeps coming up. Can you unpack how the source describes that?
Sure. Shifting cultivation, the source also calls it slash and burn or swidden agriculture, is basically a rotational farming system adapted to the forest's limitations, especially the poor soil. People will clear a small patch of forest, often by cutting down the smaller trees and burning the cleared vegetation. That fire does two things. It clears the land for planting, and the ash provides a quick temporary boost of nutrients to the soil. They then plant their staple crops. The source mentions things like tapioca, yams, maize, bananas in this clearing. But as we'll get into more detail later, the soil fertility doesn't last long. The nutrients from the ash get used up by the crops or washed away by the heavy rain pretty quickly. The source says these plots might only be usable for a few years, maybe just 2 or 3. Once the soil exhausted, the farmers abandon that plot. They let the forest start to grow back, often becoming that secondary forest, the belukar, and they move on to clear a new patch somewhere else. It's a cycle driven by the soil's limitations.
Right, it sounds like a very resource-light way of farming, dictated by the environment. And besides this temporary farming, they lived off the forest directly, too.
Exactly. Their whole life revolves around the forest and rivers. They hunt animals, birds, even reptiles for food. They fish, and they gather all sorts of useful things from the forest, edible plants, fruits, nuts, materials like rattan and cane for building or making baskets and tools, sometimes things they can trade, like wild rubber mentioned in the Amazon. The source gives examples of groups known for this lifestyle. The Pygmies in the Congo Basin, the Sakais and Orang Asli peoples in Malaysia. It's a life deeply intertwined with the natural resources immediately available.
So, traditional life. Low population density, living with the forest, using shifting cultivation and gathering. But what about, well, bigger scale human activity, settled farming, cities, industry? The source outlines some major challenges for development, doesn't it?
It certainly does. This section really lays out the fundamental geographical obstacles that, according to the source, have historically made large-scale permanent development in these equatorial regions quite difficult. It lists several interconnected problems.
Okay, what's the first one? Something about health.
Yes, poor health is listed as a significant factor. The source suggests that for people living deep inland, away from coastal resources, the traditional diet can sometimes be monotonous and lack essential vitamins. But perhaps more importantly, it points to the direct impact of the climate itself, that relentless, sticky heat and high humidity we talked about. It's described as oppressive. While coastal areas get some relief from sea breezes, the deep interior is often physically draining and uncomfortable for sustained, strenuous activity, potentially contributing to lower overall health and vitality compared to cooler climates.
And it's not just uncomfortable, the climate actively helps.
Yeah,
Nasty things thrive.
precisely. The second major challenge is the sheer prevalence of bacteria and insect pests. The hot, wet conditions are basically a perfect incubator. Bacteria multiply rapidly, and insects breed year-round. The source gives serious examples. Malaria is a huge problem for people. Many diseases and pests attack crops, making agriculture a constant fight. And it specifically calls out the tsetse fly in parts of Africa. This insect carries ngana, a disease deadly to cattle, which makes raising livestock practically impossible in large areas like much of the Congo Basin. The same fly can also give humans sleeping sickness. So these aren't just minor annoyances. They're major barriers to health and key economic activities like raising animals.
Wow, flies stopping you from having cattle. That's significant. What about the jungle itself? You said it was hard to log, but does its sheer presence cause ongoing problems?
Definitely. The third issue is termed jungle hindrance. It's not just clearing the forest initially that's hard, it's keeping it cleared. Plant life grows back incredibly quickly and vigorously. If you clear a field for crops, you have to constantly battle weeds and encroaching jungle plants that try to choke out your harvest. It requires intense, continuous effort. And building infrastructure, roads, railways, hugely difficult and expensive. You're constantly cutting through dense vegetation, dealing with swamps, navigating around massive trees. And then the jungle immediately starts trying to reclaim the cleared land. The source makes a point that in many remote areas, the Amazon, the Congo, the islands, rivers are still the main, sometimes the only way to travel and transport goods, simply because building and maintaining land routes is so incredibly challenging.
The rivers become the highways because the land fights back so hard. That really emphasizes the power of the environment. What about the ground itself, the soil?
Ah, yes, the soil. This is presented as a really fundamental problem, the fourth challenge. The rapid deterioration of tropical soil. The source explains why it happens. First, the sheer volume of rainfall leads to intense leaching. That means essential nutrients needed by plants get dissolved in the rainwater and washed down deep into the soil, out of reach of the roots or washed away entirely. Second, the breakdown of humus, that vital dark organic matter from dead plants and animals that makes soil fertile, happens extremely quickly because of the high heat and moisture. Bacteria just decompose it almost as fast as it forms so it doesn't build up.
So the goodness gets washed out, and the stuff that makes soil rich disappears too fast.
Pretty much. You start with soil that's often not very rich to begin with, outside of the nutrients temporarily locked up in the vegetation itself. And once you remove that forest cover for farming or anything else, the soil is left exposed. It erodes incredibly easily under those heavy downpours, especially on slopes. And the little fertility it had vanishes very, very quickly. The source specifically flags soil impoverishment as being worse on hillsides. It does mention one key exception, though. Areas with volcanic soils, like parts of Indonesia. Volcanic ash can create much richer, more durable soils that support agriculture better.
Okay, so unless you're on that lucky volcanic ground, the very earth makes long-term farming difficult. Are there other big hurdles mentioned?
Yes, accessibility comes up again, linked to the jungle hindrance. Just physically getting into and moving around these regions is tough. Penetrating the dense forest, crossing difficult terrain, dealing with things like river rapids, it all makes access a major challenge, which hinders exploration, settlement, and economic activity. In fact, the source, in its exercises section, explicitly calls this difficulty of access the greatest single drawback to commercial lumbering, reinforcing that point about how hard it is to get valuable timber out.
Right, it keeps coming back to just getting there and moving around.
Yeah.
And it also revisits the problem with livestock farming.
It does, listing it as another significant difficulty. It basically says large-scale livestock farming faces a double whammy. First, there's often a lack of good quality grazing land. The natural vegetation is mostly dense forest, not open meadows, especially in the lowlands. Even where there are highlands, the grass might not be very nutritious, so the cattle you can raise might be poor quality. And second, as mentioned before, diseases like ngana, carried by the tsetse fly in Africa, make raising cattle extremely risky or impossible in huge areas. So you lose out on meat, milk, and animal power.
Okay, let me try and sum up these challenges from the source. You've got the oppressive climate affecting health. You've got pervasive pests and diseases hitting people, crops, and animals. You've got the jungle itself constantly fighting back against clearing, farming, and building. Then there's the soil, which is inherently poor and degrades rapidly once disturbed. Access is incredibly difficult, and specific activities like commercial logging and livestock farming face almost insurmountable obstacles in many areas. It sounds like an environment that really stacks the deck against large-scale, settled human development as we know it elsewhere.
That's very much the picture painted by the source material, yes. It suggests that the kind of agriculture that found some footing was plantation agriculture, large scale, often foreign-owned estates focusing on specific cash crops like rubber or palm oil, which require intensive management but can be adapted to the conditions better than, say, smallholder mixed farming. The source does give a brief nod to progress in places like Malaysia, Singapore, Brazil, often through significant planning and investment. But the overall thrust of the text is really on detailing these fundamental environmental challenges that make the equatorial zone uniquely difficult.
We've certainly covered a lot of ground, digging deep into the specific climate zone based purely on this geography text. We've mapped it out, dissected the climate, explored the rainforest, looked at traditional life, and really detailed those significant geographical hurdles. Thanks again to the listener who sent this source in. It was packed with information.
Yes, it's a great example of how understanding the core geographical factors, the climate, the vegetation, the soil, helps explain so much about a region. It connects directly to why populations might be distributed the way they are, why certain economic activities thrive or struggle, the kinds of adaptations people develop. It really boils down to these key features we've discussed. The constant heat, the massive rainfall, the incredible biodiversity locked up in that dense, layered rainforest, and flowing from that, the inherent challenges related to health, pests, soil fragility, access, and the difficulty of conventional farming or logging.
This has been a fascinating deep dive, grounding us in the geographical realities described in this text.
And, reflecting on everything, the source details all those significant hurdles, the poor soil fertility, the relentless pests and diseases, the sheer difficulty of clearing the jungle and just getting around. It leaves us with a really compelling question, doesn't it? Given these profound environmental challenges laid out so clearly in this text, how did human societies in these equatorial regions manage to eventually develop complex civilizations? And how, in some cases, have they built thriving modern economies and huge cities that exist today? What amazing adaptations, what technological breakthroughs, what different forms of social organization going way beyond shifting cultivation or just plantation agriculture must have been needed to overcome, or at least navigate, these fundamental geographical constraints that Go Cheng Liang describes so well.
That is a really powerful question to end on. Because you look at places today, Singapore, Kuala Lumpur, major cities across Indonesia or Brazil, bustling, modern centers, and you contrast that with the picture painted by this foundational geography text, highlighting all the inherent difficulties. It really makes you appreciate the sheer scale of human ingenuity, adaptation, investment, and maybe transformation of the environment that must have occurred to bridge that gap between the geographical givens we've discussed and the modern reality in many of these regions. We've stuck to the source's focus on the environment itself, but the human story built on top of that environment is clearly vast and complex. Definitely something for all of you listening to think about. How do modern societies in these equatorial belts function, despite or perhaps because of the ways they've learned to manage these core geographical challenges we explore today? And on that note, we'll wrap up this deep dive. Thanks for joining us as we explore the hot, wet equatorial climate, and please do keep those sources coming. We really enjoy digging into them with you. We'll see you on the next one.